in a room so bright, talking science under starry skies. Artificial minds of space inside, deep dive podcast taking flight. Cosmos mysteries they unfold, machines with wisdom, stories told. Future secrets, brave and bold, deep dive making hearts behold. Deep dive into the unknown. Science stars and minds have grown. Deep dive, voices so clear. Journey with us far and near. Deep dive into the unknown. Science stars and minds have grown. Deep dive, voices so clear. Journey with us far and near.
Okay, so get this. An entire world encased in ice, but under that frozen shell, a hidden ocean.
An ocean so massive it makes all the water on Earth look like, well, a drop in the bucket.
We're talking about Europa, right? Jupiter's mysterious moon.
Right. And the best part, scientists now believe this moon, this icy moon, could be home to life.
Life beyond Earth. It's the ultimate quest, isn't it? And on today's deep dive, we're going to break down exactly why Europa is at the top of the list for potential life-bearing worlds.
It starts with the sheer volume of water. Europa could have twice as much water as all of Earth's oceans combined. Think about that for a second. We're not talking about a subterranean lake. We're talking about a potential global ocean.
An ocean that could be teeming with life. But it's not just about the water, is it? What else makes Europa such a prime candidate?
There's growing evidence that beneath all that ice, you have hydrothermal vents. These are basically like underwater geysers, spewing out heat and chemicals from Europa's core.
So even though sunlight can't reach those depths, there could be other sources of energy.
Exactly. Hydrothermal vents could be providing the fuel for entire ecosystems to thrive, completely independent of sunlight. We've seen it here on Earth, so it's not a stretch to imagine it happening on Europa, too.
Okay, so picture this. A hidden ocean, heated by volcanic vents, and potentially teeming with alien life. It's like something straight out of science fiction. So how do we get past all that ice and see what's really down there?
That's where NASA's Europa Clipper comes in. This is the largest spacecraft NASA has ever sent to explore another planet.
We're talking bigger than a basketball court, right?
Yeah.
Packed with instruments, all laser-focused on unlocking Europa's secrets.
It's a mission decades in the making. And it all comes down to three main objectives. First up, we got to crack the code of Europa's icy shell. How thick is it? Is it one solid chunk? Or is it more like a jigsaw puzzle with pieces that move around?
Because if those ice sheets are shifting,
Yeah.
that could mean
there are areas where the ocean below is closer to the surface, making it easier to study. And who knows, maybe even find evidence of life.
Okay, so that's objective one. Figure out the ice situation. What's next on the agenda?
Next, we dive into the ocean itself. We need to know what's in that water. Is it salty, like our oceans? What kind of chemicals are swirling around down there?
Are we talking organic molecules, the building blocks of life as we know it?
That's the million-dollar question. And Europa Clipper is equipped with instruments to give us those answers.
You're basically hot on the trail of alien DNA, right?
Well, not exactly. But finding organic molecules would be a game changer. It would be the strongest evidence yet that Europa has a potential to support life.
Okay, before we get ahead of ourselves, there's one more key objective for this mission, right?
Right. Europa Clipper is also going to map the moon in incredible detail. We'll get a better understanding of its geology, its history, and whether it has all the right ingredients to be truly habitable.
So we're talking about a mission that could rewrite our understanding of where life can exist in the universe. Pretty high stakes.
Yeah.
But hold on a second. Aren't we forgetting something? This is Jupiter we're talking about, home to the most brutal radiation in our solar system.
You're not kidding. Jupiter's magnetic field is like a giant particle accelerator, trapping charged particles from the sun, creating this intense radiation belt that could fry a spacecraft's electronics in an instant.
Okay, so we've got this amazing spacecraft ready to explore this potentially life-bearing ocean moon. But it's basically flying into a cosmic danger zone.
Yeah.
How do you even begin to engineer something that can survive that? I mean, it's got to be more than just slapping some extra layers of aluminum foil
Yeah.
on the outside, right?
It's a bit more sophisticated than that. Think of it like this. The spacecraft has this special vault, a radiation-hardened vault, where all the vital electronics are housed.
So kind of like a lead-lined safe, right in the heart of the spacecraft, protecting the brains of the operation.
Exactly. That's where the most sensitive instruments are stored, shielded from the worst of Jupiter's radiation. But that's only part of the solution. We also had to get really creative with the mission's flight plan.
Okay, so how do you choreograph a spacecraft around a radiation inferno? What's the game plan here?
Europa Clipper isn't going to just hang out in orbit around Europa, taking the full brunt of that radiation. Instead, it's going to take a more strategic approach, orbiting Jupiter, and making these close flybys of Europa.
Like a hit and run.
In a way, yes. It'll swoop in close, grab a ton of data, and then swing back out to a safer distance before the radiation can do too much damage.
It's like threading a needle through a cosmic hurricane. Even with these quick flybys, though, isn't it still going to be bombarded with a pretty hefty dose of radiation?
Oh, absolutely. We're still talking about an incredibly harsh environment. Think about it this way. Each flyby will expose Europa Clipper to the equivalent of millions of chest x-rays.
Millions.
Millions. But remember, this thing is built tough. It's designed to withstand these extreme conditions.
It's amazing what they can do these days. But okay, let's back up for a second. We've got our radiation-proof spacecraft, ready to brave the perils of Jupiter. But how long is this journey even going to take?
Well, it's not exactly a quick trip to the grocery store. We're looking at a journey of about 5.5 years to get Europa Clipper from Earth all the way to Jupiter.
5.5 years. That's longer than some college degrees. I guess it really puts into perspective just how mind-bogglingly vast space is.
It's true. And it's not a straight shot either. We're actually using a clever trick called a gravity assist to get us there.
A gravity assist? Now you're just messing with me, right? What is that exactly? Like a cosmic slingshot or something?
You got it. Think of it like this. Imagine you're swinging a ball on a string. As you spin, the ball gains momentum, right? A gravity assist works in a similar way. Europa Clipper will first fly close to Mars, using the planet's gravity to basically slingshot itself into a faster trajectory towards Jupiter.
Wow, so we're using the gravitational pull of other planets to give our spacecraft a boost? That's incredible. It's like we're playing cosmic billiards out there.
It's a testament to the ingenuity of the engineers and scientists behind this mission. They're using the laws of physics to our advantage, to explore the far reaches of our solar system.
I mean, it's really mind-blowing when you think about it. We're willing to wait over 5 years to send a spacecraft on this incredibly complex roundabout journey, all for the chance to unlock the secrets of a moon that might just hold the key to whether or not we're alone in the universe.
It's a question that has captivated humanity for centuries. And now, finally, we're on the verge of potentially answering it.
And speaking of answering big questions, we can't forget about the message in a bottle campaign. Talk about a poetic touch to a space mission.
It's a beautiful idea, isn't it? Etched onto a microchip, onboard Europa Clipper, is a poem by the U.S. poet laureate Ada Limon, titled In Praise of Mystery, a poem for Europa.
In praise of mystery. I like the sound of that already.
Alongside the poem are the names, millions of names, of people from all over the world who signed up to have their names sent to this distant ocean moon.
So we're sending a message in a bottle across the vast cosmic ocean, a message of curiosity, of hope, of our shared humanity.
It's a reminder that this mission is about more than just science and technology. It's about our shared human spirit, our innate desire to explore, to understand our place in the universe.
And you know, it really makes you wonder, what if we find something? What if Europa Clipper confirms that there's life out there? How would that change our perspective on everything?
That's the million-dollar question, isn't it? A question that could fundamentally shift our understanding of life, the universe, and our place in it all.
Yeah, it really is the biggest question, isn't it? Are we alone? And if we're not, what does that mean for us?
I mean, imagine, for millennia, we've looked up at the stars and wondered, are we alone? Are we special? And suddenly, we have an answer.
It kind of throw a wrench in things, wouldn't it? All our philosophies, religions, our entire understanding of ourselves.
It would be the biggest discovery in human history, no question. And it would force us to rethink our place in the cosmos.
And what about on a more practical level? Would finding life on Europa change how we treat our own planet, knowing that there's potentially a whole other world out there?
That's an interesting question. It certainly highlights the preciousness of life. And maybe, just maybe, it would give us a much-needed wake-up call to take better care of the one planet where we know for sure life exists.
And the scientific implications. It's almost too much to comprehend. We'd finally have something to compare ourselves to see if life follows the same rules everywhere, or if it takes completely different forms on other worlds.
Imagine the collaborations. Scientists from all over the globe, working together to unlock the secrets of alien biology. It would be unlike anything we've ever seen before.
It really puts things in perspective, doesn't it? All the problems we have here on Earth, they seem almost insignificant compared to the vastness of space and the possibility of other life out there.
But that's the beauty of exploration, isn't it? It broadens our horizons. It challenges our assumptions.
Yeah.
And it reminds us that there's still so much out there left to discover.
And speaking of discoveries, even if Europa Clipper doesn't find definitive proof of life, just imagine the incredible things it will find, the data it will gather. It has the potential to revolutionize our understanding of ocean worlds, not just in our own solar system, but across the galaxy.
Exactly. This is about so much more than just Europa. This is about pushing the boundaries of human knowledge and paving the way for future generations of explorers.
We're talking about a mission that's pushing the limits of technology. Engineering. Human ingenuity. It's really an inspiring story, and it makes you realize that we're living in a pretty remarkable time, don't you think?
Absolutely. We're on the cusp of a new era of space exploration, an era where we're not just visiting other worlds, but truly beginning to understand them.
That's enough to make your head spin. In the best way possible, of course.
It's a good kind of dizzying, isn't it? The kind that comes with realizing just how vast and mysterious the universe truly is.
Well said. Well said. So as we wrap up this deep dive into the incredible world of Europa and the groundbreaking mission of Europa Clipper, one question remains. What will we find? Will it be proof of alien life? Or something completely unexpected?
One thing's for sure. The answers we find, whatever they may be, will forever change our perspective on our place in the cosmos.
And on that note, we'll leave you with this thought. Keep looking up, keep asking questions, and never lose your sense of wonder, because who knows what amazing discoveries await us just beyond the horizon. Thanks for joining us on this deep dive, and until next time, keep exploring.